Welcome to Unit 8. We start this unit by revisiting an old friend. We're going to talk about functions. This whole unit is going to be about functions, different types of functions, and different ways of looking and analyzing functions. Today is really defining what a function is again. We've talked about it a little bit in the past, but we're going to spend a lot of time on this video and then in our next class doing the same thing and just really redefining it and taking a look and analyzing them. First, we want to review function notation. Remember, f of x equals 2x plus 1 is just another way of writing y equals 2x plus 1. So whenever we see f of x, it's another way of writing y. Those two are interchangeable. If my function is f and it's f of x equals 2x plus 1 and I ask you to find f of negative 5, I'm asking you to substitute negative 5 in for x. So we have 2 times negative 5 plus 1. And now it's an order of operations or a calculator problem. We get negative 10 plus 1, which is negative 9. So we would say that f of negative 5 is equal to negative 9. Go ahead and press pause and try g of x equals negative 2/3 x plus 15. Find g of negative 6. If you got g of x or g of negative 6 equals 19, you're correct. If you did not, check how you used your calculator. Make sure you put negative and then the 2/3 inside parentheses before you multiplied by another negative 6. Now we're really going to focus on 3 different images of what functions are, starting by looking at the graph, then looking at a table, and then looking at a set of ordered pairs. First and foremost, with a graph, we know that a function is a specific type of a relation in which each input has only one output. Go back to Unit 1 and remember, input is my x values and output is my y values. So by definition, every time I have an x, I have the exact same y. Each input or each x value is assigned one output or one y value. That'll never overlap. We can tell from a graph by doing what we call the vertical line test. So I'll first start by defining that in the box here and then go back and look at these graphs. The vertical line test states that if any one vertical line, so 2 things that are important there, it has to be one and it has to be a vertical line, touches the graph. By touches the graph, I mean intersects the graph, more than once, it's not a function. The graph is not a function. It would just be considered a relation. Okay, so remember, vertical line is the up and down line. It's the y-axis. So let's look at these examples and why the graphs on the left are functions, the graphs on the right are not. So I've been careful to make this line as vertical as possible. Assume that's perfectly vertical. The graphs here on the left are functions because as I scroll across, there's never a point where it intersects the graph or the ordered pairs more than one at a time. I can move it and intersect 2, but the point is it has to be any one vertical line. That's one vertical line, it touches the one point. Same down here. No matter where I put it, it's never going to intersect the graph more than one time. There's one intersection. The major difference is I come over here and I can put this in places like this. It intersects the graph more than one time. 2 intersections with the graph means this is not a function, it's just a relation. If I have a set of just ordered pairs plotted, I can say the same thing. This intersects those 3 points. That means it is not a function because it touches 3 ordered pairs at the same time, whereas up here it only touched 1 at a time. Down here it touches 3 at a time. Not a function. So that's how we define or use the vertical line test. Let's take a quick look at another example. It doesn't matter what the graph looks like. I can make the graph curve as many times as I wanted it to, as long as I don't have a vertical line that crosses through and touches it more than once. It's a function. I didn't do the best job there because I curved it inside here, so maybe it looks a little bit more like this. That doesn't curve back, so no vertical line would ever touch this at more than one time. Compare that to something like this graph. Okay. This time I would have a vertical line. I could just make one example and say, look, it intersects twice. This one input value, because my x is my input value, has two output values, because the y is my output values. So by the vertical line test, we can tell if a graph of a function is a function or just a relation. On the next page, we can do the same sort of analysis from a table. And this rule is as such. If any one x value has more than one y value, it's not a function. So the table on the left is a function, the table on the right is not a function, because as we look at these tables, the most important thing is here, no x value repeats. If no x value repeats, then there's no way of an x value having more than one y, because all the x values are unique. That's definitely going to be a function. But the major difference as we look at the relation table is we see that 5 is an x value that repeats. 7 and 3, no big deal. Okay, but the 5 repeats, which is okay. Your x values can repeat as long as when your input, 5, is the exact same output. In this case, I input 5, get 14. In this case, I input 5, and I get 22. It's because my y values are different. When my x values are the same. That's why I know this is not a function. So a third type of example would be, hey look, my x values repeat. I have -2, -1, 0, -1. My x values are the same. But that alone does not make this just a relation, does not eliminate it as a function. As long as, let's say we have 6 and 8 and 10 and 8. The key here is that that is the same as this, but they both map to the same number. Since those are the same, this is still a function. It's definitely a function because every x value has only one y value. The x value of -1 only has a y value of 8. And the last thing that we have to look at to determine if something's a function or not is just given a set of ordered pairs. Instead of writing anything special in here, I'm just going to say same rule as table. It's the same rule as what we have just talked about with the table. And in fact, oftentimes it's easiest to just look at this as a table. Create your own table. These are your x coordinates, y coordinates. So create a table of x, y coordinates. You have -2, -6, that's one ordered pair. 5, 10 is your second, and 12, 6 is your third. Nothing repeats for x, definitely a function. If we do the same thing here for my y values, I have 4, 9, I have 8, 7, I have 4, 3. My 4's repeat, these are the same, and these are different. That makes it just a relation, not a function. Okay, so going back real quick, if they're the same x values with the same y values, function. Same x value, different y value, not a function. And real quick, let's give you a set of ordered pairs here and see what you can come up with. If I had 5, 1, 6, 0, 7, negative 1, and 6, 4. Determine if that's a function or not. Press pause and write down your answer. By our rules, this is not a function. It has the same x values in these two ordered pairs, 6 and 6, but the y values are different, 0 and 4. That makes it not a function.